Last video. 8.5, conditional probability and independent events. Conditional probability. For equally likely outcomes, conditional probability is found by reducing the sample space to event F and then finding the number of outcomes in F that are also in E. Therefore, this is what we have. Okay? So let's see how we can tackle this. So, A is let C be the price of the stock was 0 to 49.99. First, before we continue, in the book it had, so I'm going to have this as a recall, that the P of A is equal to the dividend yield of 2% or higher. And this was in the book, so we'll consider this as a P of A, okay? So now let's start. A, let event C be that the price of the stock was from 0 to 49.99. Find okay? So this is equal to the probability that a stock has a dividend yield of 2% or higher, given that the price of the stock is 49.99. Sorry, from $0 to 49.99. Okay. So we must have A intersects C, where C is price, so this is it. And the intersection of that, so we have this, and we have this. So our intersection for this one is 68. And my C is 158, which is approximately 0.4304. Let's make this a lot smaller because it's not going to fit. Okay. So B. Let event D be that the price of the stock was 50 to 99.99. Find P A of D. So P A D. So this is going to be equals A intersection D over intersection D. Okay. So let's erase everything from here to have it clear. Now, again, this is D, and that is A. So again, we have equals 102 out of 207, which is approximately 0.4928. Now we're at C. Let's again erase our little table so it's easier to see. Now they changed it, PB of A. So it says find PB of A. But on this occasion, we have that this is the same thing as PA of B. So A would be this with the change of this. So we have 45 out of 215. Because we have B, so this time we're going down. That's why we're using this, which is different from what we were doing before. And that is approximately 2093. And erase here. D is find complements. Okay? So, to do that, we're going to do N, B intersection A over NA. So let's erase everything in here to see if we can see this better. So we have B. So we have 21 plus 69 plus 18 plus 87 over 158 plus 207. That's going to give me 195 over 365, which is approximately 0.5342. So don't worry about the other one. The other one's a little bit confusing, but the rest are going to be a lot easier. So, Venn diagrams can be used to illustrate problems in conditional probability. For instance, the Venn diagram for the previous example in which the probabilities are used to indicate the number of set defined by each region. There we go. So, PE is equal to 0.4, P of F is equal to 0.5, and P union of F is equal to 0.7. Find P conditional probability of P of EF. Okay. So we have that P. Now, remember for that we need the intersection and we have the union. So we have to use past theorems, which we're going to be using PU of F is equal to P of E plus P of F minus P E intersection of F. So that's 0.7 equals 0.4 plus 0.5 minus P E intersection F. That's 0.7 equals 0.9 minus P E intersection F. So negative 0.2 equals negative P E intersection F, which equals the probability of E intersection F is 0.2. Now with that we can use the formula for PE of F, which equals PE intersection of F over probability of F, which equals 0.2 over F was 0.5. This I can put it into 20 over 50, which is 2/5, which is approximately 0.4. Okay, so we need two fair coins were tossed and it is shown that at least one was a head. Find the probability that both were heads. Okay, so we're going to have our sample space equals head, tails, head, tails, head, tails. So our sample space is head, 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 tails, tails, head, tails, tails. That's my sample space. So for E1, event 1, at least one head. So that's going to give me at least HH, HT, TH, and that's going to be 3/4. For the second event, two heads, that's HH, which equals 1/4. So now we're going to use the P of E1. E2 is equal to 1/4 over 3/4, which equals product rule. If the probability of E does not equal the probability of F, which does not equal to 0, then the definition of conditional probability shows that the conditional probability of EF is equal to the probability of E intersection F over P of F, and P of F, conditional probability of FE is equal to PF intersection E over P of E. And using the fact that P intersection E is equal to PF intersection E and solving each of these equations for the intersection E of F, we obtain the following rule. So, important again. So, example 4, according to data from the U.S. Census Bureau, we can estimate the probability that a business is female-owned. So, probability of female-owned is equal to 0.3595. And I'm going to name it P of F, the probability of P of F. The probability that the business has 1 to 4 employees, given that it's a female, it's 57.90. So, female owned and 1 through 4 employees is equal to, I'm going to put that at P of E. So then we have, and that's a probability of 5709. So here I have PF intersection E is equal to 0.3595 times 0.5709, approximately 0.2052. And that's my answer, I believe. Perfect. Remember, this is okay. Example 5. A company needs to hire a new director of advertising. It has decided to try to hire either person A or person B, both of whom are assistant advertising directors for its major competitor. To decide between A and B, the company does research and the campaign management managed by A or B, none are managed by both, and finds that A is in charge as twice as many advertising campaigns as B. Also, A's campaigns have yielded satisfactory results 3 out of 4 times, while B campaigns have yielded satisfactory results only 2 out of 5 times. Suppose one of the competitors' advertising campaigns managed by A or B is selected randomly. Find the probability that A is in charge of a campaign and it produces satisfactory results. Oh, that was a mouthful. So let A does the job. So A does job. And let B does the job. S equals satisfactory. U unsatisfactory. Okay. So for A, so twice, so that's going to be A, B. That means A does the job or B does the job. And then we have satisfactory, unsatisfactory, B, satisfactory, unsatisfactory. So how many jobs does A have? Let's go back. Company does research and finds that A is in charge has twice as many advertising campaigns as B. So let's say twice. Also yielded satisfactory results 3 out of 4 times. Can have 2 out of 5 times. So I'm just going to put 2 out of 3, and this is 1 out of 3. Okay. Now also a campaign yielded satisfactory 3 out of 4 times. Satisfactory for A. And if that's so, then we have that unsatisfactory be 1/4. This one's 2/5. Therefore, this is 3/5 to be unsatisfactory. So there we have 2 over 3 times 3 over 4, which equals 2 over 4, which equals 1/2. 2 over 3 times 1 over 4, 2 times 2. That's going to give me 1/6. This is 1/3 times 2 over 5. That's going to give me 2 out of 15. And lastly, 1/3 times 3/5 equals 1/5. If we add all this up, this is going to be 1 total. So we're good. We're finally ready to answer the questions. A. Find the probability that A is in charge of a campaign and it produces a satisfactory result. That's going to be this one. So 1/2. B. Find the probability that B runs the campaign and produces satisfactory results. That's going to be B satisfactory. So that's going to give me 2 out of 15. C. What is the probability that the selected campaign is satisfactory? Okay, so that's PA intersection S plus PB intersection S equals 1/2 plus 2 out of 15, which equals 19 out of 30. A, B, C, D. And D states, find the probability that the selected campaign is satisfactory. Okay, so PA intersection U plus PB intersection U equals A unsatisfactory, that's 1/4. That's 1/6 plus B unsatisfactory 1/5. D is 6 plus 5 over 30, which is 11 over 30. Find the probability that either A runs the campaign or the results are satisfactory or possibly both. Find the probability that either A runs the campaign or the results are satisfactory, or both, or possibly both. So E, so that we have P of A that's gonna give me plus, sorry, no. Find the probability that either A runs the campaign, so it's A, so that means it's 1/2 plus 1/6 plus, or the results are satisfactory, so 2/15. That's gonna give me 15 plus 5 plus 2 over 30 equals 20, 22 over 30, which is 11 out of 15. Jury selection. Suppose 6 potential jurors remain in a jury pool, and 2 are to be selected to sit on the jury for the trial. The races of the 6 potential jurors are 1 Hispanic, 3 Caucasian, and 2 African American. If we select 1 juror at a time, find the probability that 1 Caucasian and 1 African American are drawn. So again, we have 3 possible answers. So those are Caucasian, Hispanic, and African American. Right? So for the Caucasian, we have 3 out of 2, which equals 1/2. For the Hispanic, that's 1 out of 6. And for the African American, 2 out of 6, which equals 1/3. And then we have Caucasian, Hispanic, and African American. This becomes 2/5 because we already chose 1, so it has to be, it's not 6 anymore, it's only 5. 1/5 and 2/5. So we have for the Hispanic, and we're not going to use a double Hispanic because we only have 1. So we only have Caucasian and African American. So we have 3 out of 5 to be chosen for the Caucasian and 2 out of 5 for the African American. And then we have the Caucasian, again, 3 out of 5 for this one. The Hispanic is 1 out of 5. And the African American would be 1 out of 5. Now, we need to find the probability that it's 1 Caucasian and 1 African American. So it's going to be this choice right here and this choice right here. So that's going to be 1/2 times 2/5 equals 1/5. And then I have 1/3 times 3/5 equals 1/5 as well. Since the events are disjoint, we add the probabilities. So we have 1/5 plus 1/5 equals 2/5. So that's my answer. 7. Two cards are drawn without replacement from another ordinary card. Find the probability that the first card is a heart and the second card is a red. Okay. So First card is a heart. Not a heart. And then we have red, black, red, black. So it's going to be 13 out of 52, which equals 1/4. This is going to be 39 out of 52, which equals 3/4. And then we have reds. Now remember, hearts are reds. So that's not going to be, you already took at least one. So that should have been 26. But now since we took one out, we're 26. It's 25, sorry. And again, we took one out, so we only have 51 cards now. But however, with blacks, we do have 26 out of 51. And that's pretty much it, all we have. Okay? So, P of heart first and red second is equal to 1/4 times 25 out of 51, which equals 25 out of 204, which is approximately 2.1225. So 8. 3 cards are drawn without replacement from an ordinary deck. Find the probability that exactly 2 of the cards are red. Okay. So red, black. We have 26 out of 52 on this occasion. 26 out of 52. Then another one is drawn. And we have red and black. Now we have 25 out of 51. And we have 26 out of 51. Because the red was chosen. Then a third time, red, black. So now we have 24 out of 50. And we have 26 out of 50. We have red. So we got a red. So that's 25 out of 50. And black will also be 25 out of 50 in this occasion. Then we have red, black. So this is 26 out of 51. And this is 25 out of 51. Red, black. So this will give me 26 out of 50 and 24 out of 50. No, this is 25, sorry, I apologize. 25 out of 50, and this should be also 25 out of 50. And we have red, black for the last one. We only gotten blacks here, so that's 26 out of 50. And this should be 24 out of 50. So, find the probability that exactly 2 of the cards are red. So this is going to be this one, because we only want 2. This one. This one. So those are all of them. So following the procedure, we have 26 out of 52. Then we have times 25 out of 51 times 26 out of 50 plus 26 out of 52 times 26 out of 51 times 25 out of 50 plus 26 out of 52 times 26 out of 51 times 25 out of 50. This is 507 over 1326, which is approximately 3824, or 38%. E and F are independent events if the probability of F of E equals P of F and PE of F is equal to P. If the event is not independent, then the event is dependent. When E and F are independent events, the probability of E intersection F is equal to PE times PEF, which equals to PE times PF. Conversely, this equation holds. It follows that P of F is equal to PEF, then we have that right there. Okay? So a USB flash drive requires two-step manufacturing process. First step. So I'm going to name that one PA, and it's circuit board. And what does it say about it? Let's assume that 98% is satisfactory, so I'm going to say 0.98. The second step involves plastic casing, so I'm going to put PB for plastic, and that has a 0.965 probability. And these are two completely different independent events. So using the theorem we just saw, we can say this. So 0.98 times 0.965 is equal to 0.9457. So, and that's it. Among partnerships and corporations that file tax returns in the United States, the probability that the enterprise consists of a firm dedicated to real estate rentals or leasing is 0.2498. The probability that the firm is a partnership is 0.3672. The probability that a firm is dedicated to real estate rentals or leasing or is a partnership is 0.4367. Are the events of the firm dedicated to real estate rentals or leasing and a firm being partnership independent? Whoa. Okay, so we have E is equal to firm rent real estate rental and leasing. F is for partnership. So conditional probability PE or conditional probability of FE is equal to P of F. That's what we want to find out. So PE is equal to 2.498. Probability of F is equal to 0.3672. And probability of E union F, 0.4367. So we're going to do our math. So it's PE plus PF minus PE intersection F is equal to PE union of F. So 0.2498 plus 0.3672 minus intersection is equal to 0.4367. This becomes 0.617 minus PE intersection F is equal to 0.4367. So therefore, this becomes 0.1803. Therefore, is equal to does not equal and therefore these events are not independent. And this concludes all the material for the semester. Remember that when we come back, you're going to have tests for chapter 8. After that, you're going to have your final on, let me check, give me a minute, and the 8th, and that will conclude the whole semester. It was a pleasure working with you guys. So please study, do your homework, and I hope you enjoyed your Thanksgiving.